Hi students, in this video we're going to discuss compound interest and problems that apply to compounding. And we have two formulas for compounding interest. A equals P times the quantity 1 plus R over N to the NT power, or A equals P times E to the RT power, which we commonly call the PERT formula. This PERT formula is used only when it says that your interest is compounded continuously, or anything is, if they use the word continuously, you use this formula, PERT. A for both formulas represents the final amount. It can be the final amount of money, the final amount of bacteria, whatever it is. P represents the original amount of money, the original amount of cells, whatever it is. N is only used in the first formula, and it represents how many times money will be compounded in a year. If they say monthly, that's 12 times a year. If they say daily, that's 365 times a year. If they say quarterly, is 4 times a year. And T is the last variable. It's in both formulas and it represents time in years. So if they say 6 months, we have to use 0.5. 6 months is 0.5 years. Okay, let's check out a couple problems, and I'll go through as quickly as I can. Matt invests $5,660. That's the principal. That's the original amount of money in a retirement account with a fixed annual interest rate of 7%. That's R, the interest rate, compounded continuously. That is the PERT formula. So we're going to use A equals P times E to the RT power. That's your base E, like natural log base E. What will the account balance be after 15 years? 15 years is how much time you're going to leave the money in. Okay, so we're finding how much money will be in the account after 15 years. So we're finding A. P is 5,660 times E to the RT power. So the interest rate is 7%. So 7% as a decimal is 0.07 times T. T is 15 years. I'm going to break to do this in the calculator. Be back. And I get $16,174.31. If we check out number 2, it says Ming invests $7,096. That's the principal in a savings account with a fixed annual interest rate of 3%. That's our interest rate. Compounded continuously, again, the PERT formula. How long will it take? How long will it take? That means you're looking for T for the account balance to reach $8,000. So this is the final amount, $8,000. So we fill in A, $8,495.45 equals P, $7,096 times E to the RT power. R is 3% as a decimal, that's 0.03, times T. T is what we're trying to find. In this problem, notice that we're multiplying both sides by 7,096. So let's, or not both sides, one side. So let's divide by 7,096 on both sides. 7,096. Time out. And after dividing, I get 1.1972 equals e to the 0.03t power. This is where we're going to take it and write it in log form at this point. So this is going to be natural log, our base e, which is understood. You don't have to put it in the base. Logarithms are equal to the exponent, so 0.03t. And this number, the answer, goes right here, 1.1972. I'll be right back. All right, I divided both sides by 0.03. So in Desmos, I took the natural log of 1.1972 divided by 0.03, and I got 5.9995, or 6 years. We might jump around a little bit. Let's do number 5. Scott invests $4,346. This is his original amount in a retirement account with a fixed annual interest rate of 5.08. That's the interest rate. Compounded 2 times a year. That's N. N is 2. What will the account balance be after 20 years? 20 years is T. So we're using the first formula, 1 plus R divided by N to the NT power. So how much money will be in the account if the original amount of money is $4,346 times the quantity 1 plus the interest rate is 0.0508. That is written as a decimal, divided by N. N is 2. That's how many times it's compounded a year, to the NT power 2 times 20 power. So I'm going to take my Desmos calculator and I'm just going to type this in literally just the way this is. And I'll be right back with the answer. Here I can show you how I put it into Desmos, and I got $11,852.84. And you just type it into Desmos just the way it is. All right, let's check out, oh boy, let's check out the next one. Jill invests $6,288. This is her original amount. Fixed annual interest rate of 8.02%. That's the interest rate. Compounded 2 times a year. That's N. How long will it take? So you're finding T to reach a final amount of 13,000. So the final amount, $13,804.30, equals the original amount, $6,288, open parentheses, 1 plus the interest rate, which is 0.0802, divided by the number of times it's compounded a year, so that's 2 times a year, to the NT power, or 2T. Okay, I'll divide both sides first by 6,288. All right, I divided this and I got 2.1953, and I added this all together and I got 1.0401 to the 2T power. This is the point where you'll take it and you'll put it in log form. I would just put it in LOG form. My base is 1.0401. We know logarithms equal the exponent. The exponent's 2t. And this number will go after log, 2.1953. I'm going to do this in Desmos. This is log base. That's under function miscellaneous. Log base, I'll type this in just the way it is, and divide by 2. Desmos will do it, and it will give me time. So I can show you how I type that into Desmos right here. And I got 9.9997, actually 8. So 9.9998, which is 10 years. So it would take 10 years for the money to grow to $13,804.30. All right, these problems are all very similar in that you're finding one of the variables that they ask you for. So I'm going to stop here and let you take it from there. Actually, I'll do another one. It says number 7, Julio invests $8,000. That's the principal in a savings account with a fixed interest rate compounded 6 times a year. That's N. After 5 years, that's T. What the balance reaches $12,000. What is the interest rate of the account? So in all of these problems, you're just finding the missing information. You're solving for the missing. So the final amount, 13,000, equals the initial amount, or the principal, 8,317, times 1 plus the interest rate is the unknown. Whoops. The interest rate is what we're trying to find. And it's compounded 6 times a year to the 6 times t, which is 5. So to the 30th power. Let's divide both sides by 8,317. Divide by 8,317. All right, after dividing, I got 1.4798 equals 1 plus r divided by 6 to the 30th power. To cancel the 30th power, we are going to take the 30th root. So we'll take the 30th root of both sides. Now I did that in Desmos. I'm going to show you what I got. I got the 30th root. I got 1.0131 equals 1 plus r divided by 6. All right, let's subtract 1 from both sides. So we have 0.0131 equals r divided by 6. So to find r, the interest rate, we're going to multiply by 6. So multiply this by 6, and let's see what we get. And after I multiply both sides by 6, I get 0.0786 equals the rate. As a decimal, this is as a decimal, but as an interest rate, it's 7.86%. And that's the rate. All right, have a good day. Delta Math, if you're level, and Pre-AP has a worksheet.